In this video, we're going to go through composite functions and how we differentiate them. So when you differentiate a composite function, we have to use something called the chain rule. And that basically means differentiate a function within a function. So let's take an example. It says differentiate with respect to x, y equals 3x minus 1 to the power of 5. So what we're going to do for a question like this, dy by dx equals, now we bring the power down so we get 5, then we get 3x minus 1. Now we reduce the power by 1, which is 4. The dot means the times, and we times by the bracket, which is 3x minus 1. This little dash means to differentiate. So we get 5 bracket 3x minus 1 to the power of 4. When we differentiate this bracket, we get 3, because 3x differentiated gives me 3, minus 1 differentiated gives me 0, so I'm left with 3. Now 5 times 3 is 15, so I get 15 times 3x minus 1 to the power of 4. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we're going to start off by saying that dy by dx equals, bring the power down, so we get 3 times 3x minus 1, reduce the power by 1, which is 2, times by the differentiation of the bracket, 3x minus 1, the dash means differentiate. So we get 3 bracket 3x minus 1 to the power of 2. We differentiate the bracket, we get 3. 3 times 3 gives me 9. 9 times 3x minus 1 to the power of 2. And that's now been differentiated. So when we differentiate a function like this, don't forget, if y was equal to ln x in general, dy by dx would be 1 over x. So in this case, dy by dx, so we're going to write it as 1 over the function, which is x squared minus 3x plus 5. But now I'm going to times it by the differentiation of the bracket, which is x squared minus 3x plus 5. And we're going to differentiate all this. The dash means differentiate. So we're going to say we end up with 2x minus 3 on the numerator. And on the denominator, we get x squared minus 3x plus 5. Here's another question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. We know that y equals ln 3x squared minus 4x plus 3. So we're going to differentiate this by saying dy by dx is going to be 1 over all of this, which is 3x squared minus 4x plus 3, times by the differentiation of the bracket, 3x squared minus 4x plus 3. So on the numerator, we get 6x minus 4. And on the denominator, we get 3x squared minus 4x plus 3. Now, when you've got a function e to the power of x, I'm going to write it as y equals e to the power of mx. So when we differentiate this, we differentiate mx, which would be m, which is the differentiation from x. And then it'll be e to the power of mx. So in our case, dy by dx, our function is x squared minus 3x. So you bring that down, and I'm going to write a dash here, which means to differentiate that function, e to the power x squared minus 3x. Now when I differentiate x squared minus 3x, I end up with 2x minus 3 times e to the power of x squared minus 3x. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So remember what I said previously, that if y equals e to the mx, then dy by dx is, we differentiate mx, which is m times e to the power of mx. So we can apply that rule here. Dy by dx, we bring the function down, 3 minus x differentiated times e to the power of 3 minus x. Now that's going to be minus 1 times e to the power of 3 minus x, and that gives me minus e to the power of 3 minus x.